Hello, good afternoon, everyone. Wait, let me share my screen. Yeah, so good evening, everyone. Welcome to another interview preparation session. Today, we are going to learn about SVM, support vector machine. We are going to see some questions on this topic. So, first of all, topic, first question is, what is SVM? First of all, question. I hope my screen is visible. So, what is SVM? So, SVM stands for support vector machines, and it is a set of supervised learning methods. It is also used for classification, regressions, and also for outliers detection. This is also used to detect outliers, and it is mostly used in classification problems. Although you can use it in regression and finding outliers as well, but it is mostly commonly used in classification problem. And what do we do in SVM algorithm? We just plot each data item as a point in the dimensional space, where n is the number of features. Number of columns you have in your data set. And then we perform classification by finding hyperplane. These all are the terms we are going to use in SVM, support vector machine. So this is the common question, that what is SVM? Now, second question is, in which condition SVM are less effective? In which condition SVMs are less There are some conditions where SVMs are not used, are not that much effective. And then, which are the conditions? When the data has noise and overlapping points. In that condition, we cannot use SVM. It is not advisable to use SVM. And there is a problem in drawing a clear hyperplane without misclassifying. So if you have data with noise and overlapping points, it is not advisable to use SVM, because you might get misclassified hyperplane. You might get problem while drawing hyperplane. Next question. What do you mean by generalization error? Generalization error in SVM. Obviously, we are talking about SVM, so everything we are going to learn is about SVM only. So what do you mean by generalization error in SVM? So generalization error in statistics or in SVM is generally the out of sample error. What is generalization error? Out of sample error, which is the measure of how accurately a model can predict values for previously unseen data. The data which is previously unseen, that how correctly a model can predict values for that. This is what generalization error does. That is the mean by generalization error. The out of sample error. You can simply say it is the out of sample error, which is the measure of how accurately a model is predicting values. Okay, next question. What if data is non-linear? What if data is non-linear in SVM? Can anyone tell me what if the data we are having is non-linear? We have to create a slack variable. Whenever our data is non-linear, we will create a slack variable. This is what we do if our data is non-linear. Next question. In SVM, flat boundary called as. What is flat boundary called as? In what happened? The size, we need to increase it. Okay. Yeah. In SVM, flat boundaries called as. What do we call the flat boundary in SVM? Hyperplane. Till now we are learning, we are hearing the word hyperplane, right? What is hyperplane? The flat boundary is known as hyperplane. These are the terms you need to remember in this concept. Hyperplane, slack variable, generalization error. These are all the points. Next question. When SVMs are less effective. Earlier over here, we had seen the condition where SVM are less effective. Now we are learning that when SVMs are less effective. Although the same question, but the answer can be slightly different. When SVMs are less effective. When SVMs are less effective. What is happening? Size. Yeah. So SVM are less effective, as I have told you, that where the data has overlapping points. So there is a problem in drawing a clear hyperplane without misclassifying with noise and overlapping points. So when data is clean and ready to use. In that case, the SVMs are less effective. When our data is clean and ready to use, we don't need to create a hyperplane and we don't need to, classify the data points. So in that case, we get SVMs less effective. Next question. What is hard margin? You all have heard this word, hard margin, soft margin. So now what is hard margin? So when SVM is very rigid in classification and work extremely well in the training set, which causes overfitting, that is known as hard margin. Clear? The overfitting, whenever the SVM causes overfitting, it is known as hard margin. It happens sometimes that when SVM is very rigid in classification and work extremely well in the training set. And this condition causes overfitting, which is known as hard margin. Clear? Next question. Which type of, or you could say, what sizes of data sets are not best suited? What sizes of data set are not best suited in SVM? That is the, okay. What sizes of data set are not best suited? The answer is large data sets. Huge data sets are not suited. It is advisable not to use SVM or not to go for this algorithm when you are having huge data sets. It is advisable to use SVM for less data sets, small data sets. Next question. What does RBF kernel in SVM with high gamma value signify? What does RBF kernel in SVM with high gamma value signify? When we are having high gamma value, so what does this signify? What does this mean? So this means that the model will consider only the points near to the hyperplane for the modeling. This point is clear. The SVM model will only consider those points which are nearer to the hyperplane. It will ignore those points which are farthest to the hyperplane. So in SVM, the gamma parameter tuning signifies the influence of points, either close or far away from the hyperplane. It depends on the distance from the hyperplane, whether it is close or far away. For low gamma value, model will constrain whereas the model will capture the shape of the data set for a higher parameter, higher gamma value. Clear? So the model will only consider those points which are nearer to the hyperplane for modeling purpose. And for low gamma, the model will constrain, whereas the model will capture the shape of the data set for a higher gamma. So the higher gamma value will capture the shape and the low gamma value will constrain. Next question. What are the data points that lie nearest to the decision surface? What are the data points called which lie nearest to the decision surface? SV survival are the points nearest to the hyperplane and difficult ones to classify. SV. So what are the data points? SV are the data points which lie nearest to the decision surface, which is hyperplane. And these are the difficult ones to classify. Now, we are in all the questions, we have heard the term hyperplane, hyperplane, hyperplane. So what is hyperplane? What is hyperplane? So hyperplane is features. In SVM, hyperplane is known as features. Simple. This is just another term used for features. So hyperplane in SVM is known as features. Next question. In SVM, the dimension of hyperplane depends upon which one? The dimension of hyperplane depends upon which one? Which one the dimensions of the hyperplane depends? So the dimensions of the hyperplane depend on the number of features. It totally depends upon the number of the features the dataset is having. And on the basis of that, the dimension is decided. The dimensions of the hyperplane depends on the number of features in SVM. Next question. on which the effectiveness of SVM depends upon. On which the effectiveness of SVM depends. Can anybody tell me on which the effectiveness of SVM depends? There are 3 points. First is selection of kernel. You should select right kernel. Then the parameter of kernel. And then third, the soft margin parameters. These are the things on which the effectiveness of SVM depends. First, selection of kernel, then the parameters of kernel, and then soft margin parameter. These 3 are the things on which the effectiveness of an SVM depends. That how effective an SVM model would be depends on these points. That you should select a right kernel, effective parameters, all these things. Next, suppose you are using RBF kernel in SVM with high gamma value. Then what does this signify? Suppose you are using RBF kernel, and selecting kernel totally depend upon the data sets you are having. So suppose you are using RBF kernel with high gamma value. What does this signify? What does this signify? So it signifies the influence of points, neither near or far away from the hyperplane. And high gamma value means the model will capture the shape of data set well. So mostly, in most the cases, the kernel should have high gamma value. And what is the condition for low gamma value? That the model will be constant and include all the points of the training data set without really capturing the shape. So the value of gamma should be high. In that case, the model will capture the shape of data set well. Okay, next question is, what is cost parameter? What is cost parameter? In SVM, obviously. So what is cost parameters? So the cost parameter decide how much an SVM should be allowed to bend with the data. This is the main component of this model because this decides that how much an SVM should be allowed to bend with the data set. Or for a low cost, you aim for a smooth decision surface. And for a higher cost, you aim to classify more points correctly. For low cost and for higher cost, you have different aims. Like if you are having low cost, then your aim would be to go for a smooth decision surface. And if you are having higher cost, then means your aim changes to classify more points correctly. So it is also simply referred to as the cost of misclassification. Clear? Next point. Mention some real world application of SVM. State some or mention some, anything. State some real world application SVM. Anyone can state some real world application that we used in a real world? So basically, SVM are highly versatile models. It comes under the highly versatile models, which can be used for practically almost all real, not almost, all real world problems, ranging from whether it would be regression to clustering and handwriting recognitions, anything. So it comes under highly versatile models. We can use it for handwriting recognition, image classification, clustering of news articles, text and hypertext categorization. These are some real world applications where SVM could be used. And it could be used in any problems, whether it would be of regression, classification, or even clustering also, or detecting outliers. So you can use SVM like in handwriting recognition, image classification, clustering of news articles. So these are some real world applications where you could use SVM. Clear? Next question. Why do we use feature normalization before using the Gaussian kernel in SVM? Why do we use feature normalization before using Gaussian kernel in SVM? So we use feature normalization before using Gaussian kernel. So why do we do that? What is the use of using feature normalization? Only when we use Gaussian kernel. We do that because we do feature normalization so that the new features will dominate other. Getting my point? We do feature normalization so that the new features will dominate other two. Sometimes feature normalization is not feasible in case of categorical variables. So you have to look into your variables, like what kind of variables you are having. And on the basis of that, you decide that whether you should do feature normalization or not. But mostly it is done. Feature normalization is done. Just except in the case of categorical variables. So you need to carefully study your data set first, and then you have to decide that which kernel you have to use, and so on. Next question. What is kernel trick? Right now we have heard that use this kernel. Now what is kernel trick? So a kernel is a function capable of computing the dot product mapped in higher dimension space without actually transforming all the instances into the higher feature space. Getting my point? What is the function of kernel? Why do we use kernel, and what is the function of kernel? So a kernel is a function capable of computing the dot points of instances What it does, it just compute the dot product of instances mapped in the higher dimension space. Without actually, it does not actually transform the instances. So without actually transforming all the instances into the higher feature space and calculating the dot product. This trick makes, and what does this trick do? This tricks make the whole process much less computationally expensive. This will reduce our cost, less computationally expensive than that the actual transformation. If we have to do go for this actual transformation, our computational cost would be so much. So this trick makes the whole process less expensive to calculate the dot product. And this is the essence, this is the work of kernel trick, and this is why this is most commonly used. Because this is less expensive than the actual transformation to calculate the dot product. And it is important to calculate the dot product in the SVM. That is why we have to go for kernel trick. Clear? Next question. What is the role of C hyperparameter in SVM? What is the role of C hyperparameter SVM? There is some parameter, C hyperparameter. Now we are going to learn about the role of this parameter. Some interviewer might ask you that what is the role of C hyperparameter? Why do we use this hyperparameter? So the balance between keeping the margin as large as possible and limiting the margin violation is controlled by the C parameter. What is the function of C parameter? What is the C parameter doing? It balances between keeping the margins as large as possible and limiting the margin violation. The margin violation is controlled by C parameter. A small value leads to a wider street, but more margin violation and higher value of C makes fewer margin violations, but end up with a smaller margin and overfitting. So you need to be carefully decide the value of the C hyperparameter, because a small value leads to a wider street, but more but more margin violation and a higher value of C makes fewer margin violations. What happens when we give small value of C parameter? What does it do? It leads to a wider street. It obviously gives us wider street, but more margin violation. And if we go for a higher value of C, it makes fewer margin violation, but ends up with a smaller margin. It does not give us wider street and leads to overfitting. So if you are giving higher value of C, it will lead you overfitting. So your C hyper value should be in mid, not that much high and not that much low. So you should be careful while giving this C hyperparameter. Next question. What affects the decision boundary in SVM? There is a boundary, decision boundary, hyperplane. So what affects the hyperplane? So adding more instances of the margin of the hyperplane does not affect the decision boundary. It is fully determined by the instances located at the edges of the street called support vectors. We have learned about support vectors, right? We have seen that support vectors are the points that lie nearest to the decision surface. So, this affects the decision boundary. If you add more instances of the margin of the hyperplane, it won't affect the decision boundary. It is not going to affect that. It is fully determined or you can say, or supported by the instances located at the edges. So you should be careful of the instances located at the edges, which is called as support vectors. The support vectors affects the decision boundaries in SVM, not the hyperplane. Not by adding more instances to the hyperplane, it is not going to affect decision boundary. Your support vectors will affect the vectors which are located at the edges. Next question. What is slack variable? What is slack variable? To meet the soft margin objective, we need to introduce a slack variable. To get the soft margin, to meet the soft margin objective, we need to introduce the slack variable in our model. For each sample, we need to introduce a slack variable. It measures how much any particular instance is allowed to violate the margin. What is the function of slack variable? It measures how much any particular instance is allowed to violate the margin. And when to use slack variable? To meet the soft margin objective. In that case, we need this. Next question. What is soft margin? What is soft margin? We have seen that what is slack variable or what does slack variable do? It is used to meet the soft margin objective. Now, what is soft margin? Why it is important to meet the soft margin objective? So that we have to introduce a slack variable. So our main objective is to find a good balance between keeping the margin as large as possible and limiting the margin violation. Both we have to do. So we have to find a good balance between those. That is our main objective. What is our main objective? To find a good balance between keeping the margins as large as possible and limiting the margin violation. These are the things that should be our main goal. Instances that end up in the middle of the margin or even on the wrong side. This method is called as soft margin. Clear what is soft margin? Instances that end up in the middle of the margin or even on the wrong side. To find a good balance between keeping the margin as large as possible and also limiting the margin violation. This method is called as soft margin. And to meet this soft margin objective, we need to introduce a slack variable. Next is SVM sensitive to feature scaling. Next question is SVM sensitive to the feature scale? Is SVM sensitive to the feature scaling? The answer is yes. The SVM is definitely sensitive to the feature scaling. Why? Because it takes input data to find the margins around hyperplanes and get biased for the variance in the high values. It get biased for the variance in high values. So it is sensitive to the feature scaling. Clear? Because what it does, it takes input data to find the margin around the hyperplanes and get biased and also get biased for the variances. Clear? Next question is, what are the advantages of SVM? We need to state the advantages of SVM. So, first, we can access it conveniently. Be it from Python or MATLAB, we can access it. That is the main advantage. Secondly, SVM can be used for linearly separable as well as non-linearly separable data. For both kind of data, SVM is used. Third, linear separable data is the hard margin. Right now I told you, for linearly separable as well as non-linearly separable, we could use SVM. Now, what is linearly and non-linearly separable? So, linearly separable data means it is the data, linearly separable is the hard margin, whereas non-linearly is the soft margin. These are the difference between linearly and non-linearly separable data. Then, it can be used in areas where the data is labeled as well as unlabeled. It doesn't matter whether the data is labeled or unlabeled. It can be used in both. In both the cases, it can be used. It can be used in the area where the data is labeled as well as unlabeled. And with the help of kernel trick, SVM can carry out feature mapping using a simple dot product. This is also the one of the major advantage of SVM, that it can use kernel trick and can carry out feature mapping. And that too with using a simple dot product only. Next question. What are the different kernel functions? There are multiple kernel functions available. What are those? First, linear, non-linear, polynomial, Gaussian, RBF. RBF stands for radial basis function, and sigma. These all are the different kernel functions used by SVM. And all are different from one another. And each one of them can be suitable for a particular problem depending on the data. You need to understand the data first. And then by looking at your data, you need to find out that which kernel functions will suit it perfectly. And then you have to go for that one. Whether it could be linear, non-linear, polynomial, RBF, Gaussian, sigmoid, any kernel function you can use depending on the data. Whichever functions is more suitable, you have to go for that one. Clear? You can use any function to solve a particular problem depending on the data. Your entire problem Your entire question depends on the functions you are choosing. And to choose a right and particular correct function, you need to see the data. You need to observe the data carefully. What is the requirement of data? Whether data is linearly separable or non-linear separable, accordingly, you can go. You can opt. So these are the some interview preparation questions which could be asked related to this topic, SVM support vector machine. In this question, all the topics are covered of SVM. Hyperplane, soft margin, hard margin, kernel trick, cost parameter, feature normalization, slack variable. These are all are the important terms used in this SVM model.